Space is vast and full of wonder, but it also holds dangers. Asteroids, remnants from the early solar system, hurtle through space. Sometimes their paths cross Earth's orbit. Asteroid 2024 YR4, discovered on December 27, 2024, is one such asteroid, and it has our attention. Why? Because there's a chance it could collide with Earth in 2032. The possibility of an asteroid impact is a sobering thought. It reminds us of our vulnerability in the vastness of space, but it also highlights the importance of scientific advancement and international cooperation. We are not powerless in the face of such threats. Asteroid 2024 YR4 is estimated to be between 40 and 90 meters in diameter. This range might seem small, but in the context of space, it is quite significant. Scientists use various methods to estimate the size of such asteroids, including radar observations and analyzing the light they reflect. That's about the size of half a football field. To put it in perspective, imagine an object that large hurtling through space at incredible speeds. While it may not seem huge compared to the vastness of space, an asteroid of this size could cause significant damage if it were to hit Earth. The energy released upon impact would be catastrophic, potentially affecting a large area. The impact of an asteroid releases an immense amount of energy, equivalent to a powerful nuclear explosion. This energy release can cause shock waves, fires, and even trigger tsunamis if it hits a body of water. The effects of such an impact would depend on various factors, including the asteroid's size, composition, speed, and angle of impact. Scientists are constantly studying these variables to better predict the potential damage and develop strategies to mitigate the impact. But even a relatively small asteroid like 2024 YR4 could cause widespread destruction if it were to hit a populated area. The aftermath could include loss of life, destruction of infrastructure, and long-term environmental consequences. This is why monitoring and preparing for potential asteroid impacts is crucial for our planet's safety. Scientists are constantly tracking the movements of near-Earth objects like 2024 YR4. These objects, often remnants from the formation of our solar system, can vary greatly in size and composition. Some are as small as pebbles, while others can be miles wide. They use powerful telescopes and sophisticated computer models to calculate their trajectories and assess the risk of impact. These tools allow scientists to predict the paths of these objects with remarkable accuracy, but there are always variables that can affect the outcome. However, these calculations are not always precise. Factors such as gravitational influences from other celestial bodies, the asteroid's shape, and even its rotation can introduce uncertainties. There are inherent uncertainties in our observations and models. These uncertainties are represented by error bars and ranges, which indicate the possible variations in the asteroid's path. The initial estimate for the probability of 2024 YR4 impacting Earth in 2032 was about 1 in 83, or 1.2%. This estimate was based on the limited data available at the time. However, as scientists gather more data and refine their calculations, this probability has increased to 1 in 43, or 2.3%. This increase is due to more precise measurements and better understanding of the asteroid's trajectory. While this is still a relatively low probability, it is a significant increase. It highlights the dynamic nature of space and the importance of continuous observation and analysis. It underscores the importance of continued monitoring and preparedness. By staying vigilant and improving our predictive models, we can better understand and mitigate the risks posed by near-Earth objects like 2024 YR4. Deflecting disaster: the kinetic impactor. The prospect of an asteroid impact may seem like the stuff of science fiction, but scientists and engineers are actively developing strategies to protect our planet from such threats. One promising method is the kinetic impactor. The kinetic impactor method involves crashing a spacecraft into an asteroid at high speed to slightly alter its trajectory. This nudge, over time, can significantly change the asteroid's path, steering it away from Earth. This technique was successfully demonstrated by NASA's Double Asteroid Redirection Test, or DART, mission in 2022. Beyond the kinetic impactor, other options and challenges. While the kinetic impactor method shows great promise, it may not be suitable for all situations. This method involves sending a spacecraft to collide with an asteroid, altering its trajectory. However, the effectiveness of this approach can vary depending on the size, composition, and speed of the asteroid. For example, it might not be effective against asteroids on a near straight trajectory towards Earth, like 2024 YR4. These types of asteroids pose a significant challenge because their paths are more predictable and harder to alter with a kinetic impactor. In such cases, more drastic measures might be necessary. Scientists and engineers are constantly brainstorming and planning for alternative solutions that could be more effective in these scenarios. Scientists are exploring other options, such as using a gravity tractor, a concept that involves a spacecraft hovering near the asteroid. The spacecraft would use its gravitational pull to gradually tug the asteroid off course. This method requires precise calculations and long-term planning but could be a viable solution for certain types of asteroids. Another possibility is using nuclear explosives, which could deliver a powerful force to change the asteroid's path. But this option is fraught with political and ethical considerations. The use of nuclear technology in space raises numerous concerns and requires international cooperation and agreement. It also carries the risk of fragmenting the asteroid, which could result in multiple smaller asteroids heading towards Earth. This scenario could potentially create multiple threats instead of one, complicating the efforts to protect our planet. The Tunguska event, a stark reminder. The threat of an asteroid impact is not merely theoretical. History provides a stark reminder of the destructive power of these celestial objects. In 1908, an asteroid or comet, estimated to be about 40 meters in diameter, exploded over Tunguska, Siberia. The Tunguska event flattened over 2,000 square kilometers of forest, releasing energy equivalent to about 1,000 Hiroshima bombs. Fortunately, the impact occurred in a remote area, and there were no known human casualties. But the Tunguska event serves as a sobering reminder of the potential consequences of an asteroid impact. Vigilance and preparedness. Our best defense. The discovery of asteroid 2024 YR4 and its potential threat to Earth is a call to action. It underscores the importance of continued investment in space exploration, asteroid detection, and planetary defense technologies. We must remain vigilant, constantly scanning the skies for potential threats. International cooperation is also crucial. No single nation can address this global challenge alone. By sharing data, resources, and expertise, we can enhance our collective ability to detect, track, and deflect potentially hazardous asteroids. The future of our planet may depend on it.